I would like to preface this particular discussion by saying that fertility control in wild horse and burro populations are not without controversy. There are arguments from both sides of the table, and for some of you, or those of you in the audience that have been or are heavily involved with some of the controversial issues, if you will just bear with me for a few minutes, I would like to present some of the, to some of those that are perhaps that are not as familiar with the subject, present a brief background on some of the major issues as I understand it, or at least how I perceive the issues to be. So I think that all of you know that the BLM is responsible for the care and management of wild horses. And they've been working with different programs for many years now. But needless to say, there are approximately 40,000 free-roaming horses and burros in this country. Now, I've heard of other figures, such as 50,000 wild horses and burros, but I haven't seen any data to back up those figures. Regardless of whether it's 40,000 or 50,000, I think you all appreciate the magnitude of free-roaming horses in this country, and it's only in this country. In the holding facilities in which the BLM has, there are approximately 41 or 42,000 horses, and this number is growing on a yearly basis. And the reason why they're growing, of course, is that these horses are cared for much better than were they out in the range. I need to carry this with me, I'm sorry. I can't see that slide up there. The cost is approximately $40 million a year to care for these horses at the holding facility. And that represents a huge amount of the BLM's entire budget. Now, I heard an interesting comment just the other evening when I mentioned to an acquaintance of mine who is a horse person that how much money it costs to care for these horses in the holding facilities. And her response was, well, at least they're spending the money on equids rather than on lavish parties and entertainment. Well, I thought that was being a naive person. I did not think much of it, but on a second thought, I thought maybe that comment had a lot of merit to it. Regardless, the adoption program was a very good program, but it has, in the past few years, seen a significant decrease in the number of horse owners or people that have adopted these horses, and it's primarily for economic reasons. So in order to reduce the population of horses or free-roaming horses, the BLM has continued to do roundups despite the resistance by horse advocacy groups. The arguments against, and some of you probably already know this, but the arguments against the way horses are managed out in the range is that these roundups causes undue stress and sometimes injury to the horses. The other argument is that it depletes genetic diversity. Another argument is that there is no evidence of overpopulation, and that the BLM, or at least the government, has a lot of more land that they can turn the horses back out on. Now, I don't know if this is the truth or not, but nevertheless, these are some of the arguments. Another argument is that the horses in holding pens are inhumane. That is, they are not where they're supposed to be. Tax dollars are being spent needlessly, and that these groups, these arguments against the management, is that they prefer that all horses remain free as they were intended to be. Well, what alternatives do the people responsible for these horses have? There aren't really too many alternatives, but let's go through each one of them. We won't discuss euthanasia, particularly in this country, because it's unacceptable, and more than likely it will always be unacceptable. But needless to say, some other countries do this, and it's their own priority. The other alternative is to continue gathering these horses to reduce populations, free-roaming populations. But as you know, as you continue to gather, you continue to increase the number of horses in these holding facilities. You have to build more holding facilities, and this, of course, is cost prohibitive as it already is. Well, what would happen if nothing was done? Based on estimated growth rates, if you waited 4 years and did nothing, you would end up with approximately 80,000 free-roaming horses. Now, this is just based on estimated growth rates. On a yearly basis, it's approximately 20 to 25% of the population. If you waited 6 years, the numbers would grow up to 120,000. And this is a lot of horses, okay? Particularly if you did nothing. The appropriate management level is considered to be, at least it's described as being 20 to 30,000 free-roaming horses in all the herd areas in the United States. And how they came up on this is by modeling studies, et cetera, et cetera. So in order to reduce the populations, which they continually are trying to do, is to round up these free-roaming horses so that you can reach their desired level. Well, this translates to more horses in the holding facilities, more cost, and it has, to this date, has not been as effective as they would like it to be. At least that's my perception. So in order to reduce the number of free-roaming horses, we already talked about lethal means or lethal procedures. That's unacceptable. Surgical procedures are also not encouraged because it's also cost prohibitive to do any surgical procedure on any horse. So there are only two possibilities left for those responsible for these horses. One is to remove from the range, which is what they are doing right now. And again, it has not been as effective as they would like it to be, and for reasons unbeknownst to me, but nevertheless, they would like to gather more horses and remove more of them at a more frequent pace than they have been doing. The other alternative is to reduce the reproductive rate. And there's really only one, or there are two ways, and we'll talk about it. But one of the ways that have been approved is the contraception programs. The contraception programs in wild horses and burros have been ongoing on an experimental basis for quite some time now. And I think it initiated sometime in about 1983. And the process has been very, very slow because the numbers that have been inoculated on have been inoculated on a very small scale basis. basically a very small scale basis compared to the number of horses that are present that are free ranging. So the argument for contraception is that by law, the BLM is responsible for the appropriate management levels for each herd area. Now, if you remember or you recall just a few slides ago, the desired level for all herd areas is about 30,000 free-roaming horses. The holding facilities that are present to date are not only cost prohibitive, but they are being overcrowded. Adoption programs I mentioned previously is not working very well, at least in this economic situation. And if you multiply the growth rate, which is estimated growth rate, which is 20 to 25%, times the number of free-roaming horses that are already present, that becomes a very significant amount of horses. Can I go backward? Yes. Now, the more horses you have, you keep in mind that the more horses you have and the more overcrowded the situation is, you will subject these horses to environmental stresses such as food, forage, drought, water availability, and also disease outbreaks. And perhaps we can talk about that later. But nevertheless, the more crowded a situation is, the more you will subject these horses to these conditions. So the requirements, if you were to develop a contraceptive agent, there are many requirements. And on this particular slide are a few of them, if not most of them, but there are very stiff requirements if you are trying to develop a contraceptive agent. It has to be highly effective or it would be of no use, obviously. It has to have a multi-year duration, effectiveness for at least several years, not just 1 year, but for several years. Now, we're talking about large-scale operations, not very small ones, not 20 or 50 horses in a herd area, but we're talking about hundreds of them. Okay? If you were to develop a contraceptive agent, it should not have any effect on the sexual behavior, because sexual behavior plays a lot of role in the social structure and or band integrity. You should have no effect on the existing pregnancy in case mares are pregnant. No toxicity, that is, it doesn't have any toxic effects, not only to the horse, but also to the applicator. It should not pass through the food chain because they do not want scavengers and or predators to be affected should they have access to any of the horse carcasses. They prefer that it be delivered remotely, and that is a possibility, as we will discuss shortly, and it has to be cost effective. So again, these requirements, they're pretty stiff if you're trying to develop a contraceptive agent. Another very frequent common question is, do you target the stallions, or do you, if you're going to develop a contraceptive agent, do you target the stallions or do you target the mares? It's a nip and tuck on that. If you do target the stallions, I will remind you that a single or normal fertile stallion can, on the average, impregnate at least 40 mares per season. And I will also remind you that the subordinate stallions and the bachelor stallions can be equally as fertile. So that if you target the stallions, if you target the stallions, you'll have to target not only the dominant stallion, but the subordinate stallion and the bachelor stallion, merely because if for some reason the dominant stallion loses its herd due to the subordinate stallion, that subordinate stallion would very easily take care or impregnate the mares of that dominant stallion's herd. So basically, yes, targeting the stallion is a good thing. It can be done. But if you do that, you have to, that agent, whatever you use for targeting that stallion, cannot affect the sexual behavior of that particular stallion. And simultaneously, it has to deplete completely the sperm production of that particular stallion. Under those circumstances, yes, you can target the stallion. It would be good to target the stallion. But saying or developing an agent to do that is very difficult. And there is none available at this time that I am aware of. There are no agents available at that time. So what are the current available contraceptive agents? I think most of you heard of the word PZP, or porcine Zona Pellucida. There are 3 different formulations currently, and they're all based on a Zona Pellucida of pig eggs. As you can see, the Spayvac is one of them. Zonostat is another one. Oh, wow. And another one is referred to as PZP22. And the 22 basically refers to the fact that that particular formulation is capable of producing or being effective in being contraceptively effective for at least 22 months, almost 2 breeding seasons. The other available contraceptive agent is a hormone called gonadotropin releasing hormone. Is that me, or is that, or is it this?
When your arm hits that box there.
This box?
Yeah, yeah.
Sorry.
We've heard it before.
Yeah, the other agent that is available and quite effective is the GnRH, the gonadotropin releasing hormone. It's referred to as Gonacon, and it's produced by the Aphis USDA people. And we'll get to that particular hormone in a minute. If we very briefly discuss the Zona Pellucida, for those of you that are not familiar with the Zona Pellucida, it's this membrane surrounding the egg of a horse. And I'm supposed to be using this. It is this acellular membrane that surrounds the surface of the egg. Okay? That is called the back. That is called, darn it, that is called the Zona Pellucida. Okay? Right here. Now, the Zona Pellucida comprise of 3 or 4 epitopes or proteins, and each one of them is labeled as Zona Pellucida 1, 2, and 3. The dogma for sperm binding or attaching sites is the Zona Pellucida 3, right here. That is a sperm recognition molecule, and it has been known that this is the binding site of sperm for many, many years now. However, recently, I understand this now, system. And this is perhaps only relevant to researchers, But I just wanted you to know that a recent publication, only about 3-4 months ago, in June, actually, 4 or 5 months ago, that there's some investigation has shown, and with very good evidence, that ZP2 is the binding or recognition site for sperm and not ZP3. Again, it probably does not matter much to you, but it is interesting, and it would be interesting to some researchers in the event that they want to specifically target a certain area as a contraceptive agent for humans in particular. Some of you, and I think many of you, probably know the events of fertilization. You know that the sperm, once it reaches the egg, has to attach to the zona pellucida. Once they attach to the zona pellucida, they penetrate the zona pellucida, and as soon as that first sperm penetrates the zona pellucida undergoes a hardening, so to speak, and it prevents other sperm that are attached to the zona pellucida from penetrating and doing providing, well, not providing, but prevents many sperm from fertilizing that particular egg. And that is referred to as polyspermy. Now back to the mechanism by which zona pellucida works, or how it works. If you look at this slide on your left, or the graphic on your left, is that when sperm is present or reaches the oocyte, it binds on to the recognition site, and whether that's ZP2 or ZP3 is up in the air right now. But once it binds, it's capable of penetrating the egg, and if it penetrates the egg, it allows it to fertilize that particular egg. If you look on the right side, and if you vaccinate a mare with zona pellucida from pigs, what happens is that that mare will produce antibodies against the pig zona pellucida. These antibodies will attach onto the receptor sites, or the ZP1 or ZP2 and ZP3, and that prevents any sperm from binding or attaching on to the zona pellucida of the horse's egg. So if you don't have binding, you will not have penetration. If you don't have penetration, you will not have fertilization. And that is the mechanism, that is one mechanism, one of two mechanisms that occurs when you inject equids with zona pellucida vaccine. The other mechanism, which has recently been elucidated, is that the zona pellucida will also suppress follicular development. If you don't have follicular development, you will not have egg production or oocyte production. On the slide on your left, you will see this appears to be a normal follicle. You see how large it is compared to these small ones. And then this large follicle will contain an egg within the center of that follicle. If you inject mares with PZP, not only will you have a block of sperm from binding onto the zona pellucida, but you will also get a suppression of follicular development. Okay? That has recently been elucidated. If you don't have follicular development, you will not have egg or oocyte production. So those are the two currently known mechanisms of PZP when you inject it into equids. More justification for PZP. If you compare removal of horses with PZP injection in mares, you can clearly see the differences between the two. fertility control, we know of no known mortality associated with PZP injections in any formulation. Okay? Do you have gene pool preservation? Yes, you do, because when you vaccinate a mare with PZP, it is a reversible situation. That is, the effectiveness of the contraception effectiveness will last for only a year or 2 or 3 at the very most. And if you don't revaccinate that mare with PZP, she will become pregnant again. So therefore, you have not depleted the gene pool, and you will allow that particular mare to go ahead and have foals or become pregnant. The cost is a lot of differences between fertility control and removal. And yes, you have to round up the horses in order to inject the agent, the contraceptive agent. But over time, the less horses that you have to gather, the less mares that you have to vaccinate. And that will, over time, decrease the amount of money that is involved in vaccinating these mares. And the cost per horse per sanctuary is about approximately $1,100. And as you can see, that if you contracept the mares, each foal that is not born will reduce the sanctuary costs over time. There is one publication on donkeys, and that was done by Dr. John Turner from the Medical College of Ohio. He vaccinated the mares with PZP, Zona Pellucida, remotely. And as you can see in the red circle here, it was quite effective. 1 out of 16 jennies became pregnant. That is, at least 90%, if not more, of the mares were effectively contracepted, whereas compared the untreated controls, 6 of the 11 became pregnant, which amounts to approximately 50 to 55%. Now, this is the only publication that I'm aware of, and I think there are more studies being done, and I believe the next speaker will probably discuss that. But there are more studies being done on donkeys. This essentially, the results of this particular study confirms, at least to me, that whatever is performed or whatever effect there is on the horse with PZP, it would probably be equally as effective in donkeys. And I strongly believe that such is the case. Now, the effectiveness of PZP, some of the formulations require 2 injections, and others require only a single injection. The multiple injections is not an option for large-scale population management, because in many instances, particularly with horses in Nevada, you have only one opportunity to get to that horse. In other situations where the horses are not as wild, so to speak, or that are more accustomed to the humans, you are able to not only identify these horses, especially on a small-scale basis, you are not only able to identify these horses, but you are able to get closer to them, or at least you are able to get to them more frequently than just one single opportunity. So, single injection, if you're talking about large-scale operations, require only a single injection, and that is mandatory. In order to do that, incorporating contraceptive agent has to be done with a controlled release mechanism. Controlled release mechanisms, as you all know, is very similar to those that you use with your antihistamines. There are two types of controlled release mechanisms. One is referred to as a sustained release, and the other one is a controlled release. Sustained release merely means that it's continual release of the drug. The controlled release means that it only releases at designated times, such as 1 month, 6 months, 1 year, etc., etc. There are various formulations that are available for both the PZP as well as the GnRH agents. We won't discuss in detail what these controlled release mechanisms are, but simply suffice to say that there are one formulation comprised of liposomes and the other formulation comprised of lactide glycolide copolymers. But these two agents, allow for the release of PZP at designated times. One does, the other one is a sustained release mechanism. If you eliminate GnRH, you're going to eliminate any reproductive function in most mammalian species. What the GnRH does, it signals the anterior pituitary, which is another part of the brain, to produce and secrete what is referred to two other hormones. One is called FSH, the other is called luteinizing hormone. The FSH is referred to as a follicle-stimulating hormone, and this hormone is responsible for follicular development and oocyte development. If you don't have FSH, you will not have follicular development and or oocyte development. One mechanism of GnRH, the Gonacon product that is being used, is proposed to be that it produces, if you inject the GnRH, the synthetic GnRH into the mare, you will produce antibodies against that GnRH. Those antibodies will bind on to the native hormone, and that complex is too large to pass through a membrane, and therefore it would not signal the pituitary to produce FSH and or LH. You can't stop that, can you? The other mechanism, which is more likely what is happening when you inject the mare with the hormone, gonadotropic releasing hormone. Under normal physiologic conditions, the hormone GnRH is produced and secreted in a pulsatile fashion. In other words, when you normally or naturally, these pulsatile secretions are at intermittent levels. They are not constant, they are not continual. So when that happens, it naturally signals the anterior pituitary, or that part of the gland, to produce your FSH and LH. Okay, that is normal. If you inject a horse with synthetic GnRH or Gonacon, you get what is called a constant activation, or constant or continual activation. And what that does is that it overloads the anterior pituitary, and it refers to as a down regulation. That is, it shuts off the signal to produce FSH and LH. If you don't have FSH and you don't have LH, again, you will not have follicular development and or oocyte development. So Gonacon, the GnRH agent that is currently being used, is very effective, or is at least as effective as Zona Pellucida. And one advantage of the Gonacon agent is that it can also be used in stallions. It affects both genders. There are concerns, however, with the use of Gonacon, and that it may, over time, affect the behavior of the stallion and or the mare. And if you recall, in the earlier slide, one of the major requirements was that any contraceptive agent should not have any effect on social behavior. The other concern is that GnRH, and I'm not a strong believer in that, but one concern is that when you inject this hormone into a horse or a donkey, so to speak, it may pass along the food chain. That is, it may pass along to the scavengers and predators should they are able to get to these animals. There is only one published report in the literature on the use of Gonacon, and I think in the very near future there will be several more. We talked about the use of PZP and the use of Gonacon and how successful it appeared to be. Very recent investigations on both PZP and Gonacon, for some mysterious reason, have not turned out as well as expected. In an attempt to improve the formulation so that it lasts for 4 to 5 years, the results backfired recently, and all this is not published. I just know this for a fact, that it has not worked as well as it has intended to be. So it's basically back to the drawing table, albeit that at least Gonacon and PZP is effective for at least one breeding season or 1 year. It's just that the investigations to improve the vaccine so that it lasts for at least 3 to 5 years did not work. Okay. So the solution to produce an ideal contraceptive agent is not resolved, and the issue of overpopulation continues to escalate to the point where the agents responsible are encouraging or at least proposing for any ideal sterilant. Okay? Sterilant is different than contraceptive, as most of you know. Sterilant is permanent. Contraception is reversible or only a temporary situation. The huge difference between the two. So the agencies that are responsible for the current situation or the dilemma of overpopulation of wild horses and burros are looking for sterilants. Now, sterilants are not highly acceptable by many people because it's permanent. But what the agency proposes is that they use it for older mares only. And that isn't such a bad thing from my point of view. What are the advantages of sterilizing older mares? There are a lot of advantages. One good advantage is that the less pregnancy a mare has, the less times or number of foals a mare has, the longer she will live, because pregnancy in equids take a very big toll on these mares. The second advantage is that injuries to mares due to foaling, etc., occurs quite frequently, as many of you may or may not know, but it occurs quite frequently, particularly in the area of the cervix. And if the mare does not become pregnant, you will give the mare less chances of having injury of any sort, let alone, and most importantly, if a mare does not become pregnant, she will not be subjected to dystocias and or abortions, which do occur in mares fairly frequently. So those are basically the advantages of using sterilants on older mares. The fact that the mares live longer has already been published, and that's been published many years ago by J. Kirkpatrick of Montana, who did a very nice study on the acetic island on a small population of ponies. As far as the stallions are concerned, I think this is a very promising procedure, particularly as a sterilant. There have been some studies, I think most of you already know from the last symposium, done by Dr. Leon Pulstick, who did a study on Sheldon herd management area using a chemical drug as a form of vasectomy. And basically you inject this chemical into the vas deferens of a horse. My understanding, however, is that it was not very successful, but it had no adverse effects. Needless to say, or regardless of what the results were, I think if you found a successful chemical to use for chemical vasectomy, this would be the perfect sterilant for dominant stallions or even subordinate and bachelor stallions, because it would not have any effect on the behavior of the stallions, and at the same time you would deplete the sperm production of any stallion in which you use the procedure. So, to make a long story short, and in conclusion, are there contraceptive agents available? Yes, there are available, and they are effective. And why don't they use it for large-scale populations? Because it's not effective enough. Despite the fact that it is effective, agencies that are responsible for these large-scale operations require that the effectiveness lasts for at least 4 to 5 years. Okay. The question was,
Has that been tried?
Has it been tried? Yes, it has been tried. It has been attempted. And there are conflicting results on the use of glass marbles inserted into the uterus of mares, in case some of you are not familiar with that particular procedure. And basically what these glass marbles are, they're about 35 millimeters, I believe, fairly small glass marbles inserted into the uterus of mares, and that mimics pregnancy of a mare, okay? The initial study on glass marble use heralded a 72% success rate. But other studies did not confirm that success rate, and some publications indicate that only 26% of them were effective. So there's a conflict in results. And I think that it will work, except that many mares will lose these marbles when they come into heat. Because the cervix relaxes, the uterus becomes very edematous, and it's normal for uterine contractions to occur during estrus. When uterine contractions occur, and with the secretions placed, or with secretions and edema in the uterus, it can easily the mare can easily eliminate those marbles. It's used primarily for show horses to keep them from coming into heat during the show season. Does PZP interrupt estrus cycle? No. PZP, there are many published literature on PZP, on the use of PZP in mares, primarily written by two individuals, Dr. J. Kirkpatrick from Montana and Dr. John Turner from the University, from the Medical College of Ohio in Toledo. When you inject or vaccinate a mare with PZP, it does not interrupt estrus cycle. All it does, well, I have to back that up a little bit. Initially, for the first few years, if you give PZP, depending on the formulation, that's why I'm hesitating here. One formulation will have an effect on estrus cycle, and the other formulation will not, at least unless you give it 4 or 5 injections over the next, over 4 or 5 year period of time. Depending on the formulation, if you use Zonistat as an example, sometimes it's referred to as liquid PZP. If you use a 2-dose regimen of PZP, it will not have any effect on the estrus cycle unless you inject the mares yearly for the next 4 or 5 years. If you do that on a yearly basis, then it will have an eventual effect on the estrus cycle. However, the first year or 2 or 3 years, the mares will continue the cycle and on a regular basis, and it will not even interrupt the interval of the estrus cycle. So the answer is yes, the answer is no. That depends on what formulation you are using. The other formulation does interrupt the estrus cycle. As an example, the use of Spayvac have shown, or will be shown very shortly, that when you use Spayvac, another formulation of PZP, that will shut the mare down within 14 weeks. Now, shutting the mare down is obviously suppression of follicular development because that interrupts the estrus cycle. That may not be such a bad thing. Most people view that as being a sterilant. No one knows at this point in time whether shutting the cycle down is a permanent thing or is it only a temporary thing. Although you will hear more frequently in the next few months, if not years, that some of the PZP formulations are shutting down the mares permanently. And this actually is not true because it has not been shown that this is a permanent situation, that this is not a permanent situation, and it could be one that will last for only 2, 3, or maybe even 1 year. We will know that probably, my guess is within the next 2 or 3 years, we will have the answer for that, because there are several ongoing investigations regarding the use of all 3 contraceptive agents. But these experiments take a long time because it's a 3 or 4 year situation.
So you're talking about a sterilant in older mares. Is that the PZP?
No. The sterilant is a totally different situation now. That hasn't even been attempted in horses to date. It's just a proposal that the government agencies want to have developed in the event that they could use it on mares. There are no known sterilant at this point in time. PZP and Gonacon have all been reversible situations. You can use PZP remotely, and that would be very nice to be able to do that, but you more than likely have to use it because of the distance in which you have to be at when you deliver the vaccine remotely. The horses have to be very accustomed to humans and or traffic, and otherwise you would not be able to get close enough to deliver the vaccine remotely. It's a nice feature, but it's only useful in certain animals. If you are out in Nevada, as an example, in the wild herds, there's no way you're going to get close to those horses, close enough to remotely dart them. You know, you may be sitting in the water hole and waiting for them to come, but that would be a very, very difficult task from my perception. I may be wrong, but I think that would be very difficult to do.